Okay. Inter-objective sensitivity determination, another interesting problem. So we are optimizing two functions, say for example, two objectives, F1 and F2. We don't know how F1 is affecting F2. The problem we are harping on time and again. Now, let us put it in a different perspective. Some change in F2, how it is going to affect F1. We understand that F1 and F2 are interdependent, intersensitive. So change in one objective, how it is going to affect the change or induce the change in respect of the other. Another question. Another one is quantitative characterization of frontal decomposition in a multi-objective optimization problem. In fact, this is already we have reported, as I have mentioned. It's so. Some of which are enlisted here, but there are so many. So you are welcome to contribute. Thank you. These are certain references. Thank you for your patient hearing and all the cooperation you extended. Thank you very much.
Thank you, sir.
More questions? Any question, please? অনেক সময় নিয়ে নিচ্ছি নাকি?
Sir, can you name any practical application of your this theories?
সব কিছু যেখানেই অ্যাকাডেমিসি অবজেক্টিভ দুটোকে হ্যাঁ ডান ঝুলপিতে
Practical application
যেখানে তোমার ডান ঝুলপিতে টান দিলাম বাঁ ঝুলপিটা কিরকম ব্যথা ব্যথা করছে
এবার all optical
যে কোনো আরে রাস্তা দিয়ে যাচ্ছ তো এই রাস্তাটা শর্টে তাড়াতাড়ি পৌঁছবে মানে এক্সপেক্ট করছো শর্ট আর্টিস্ট অনেক বেশি কনজেস্টেড আর ঘুরে গেলে কনজেশন কম কিন্তু পৌঁছে বাইপাসের যে কনসেপ্ট ওটা যাবে তখন তো তুমি তখন যদি ভাবো ডিস্টেন্স মিনিমাইজ করবো আর কনজেশন মিনিমাইজ করবো আরেকটা কিন্তু দুটো ইন্টারডিপেন্ডেন্ট আমি তো দুটো দেখে একটা ডিসিশন এটা প্রচুর ইঞ্জিনিয়ারিং এ তো ভুড়ি ভুড়ি আছে ইলেকট্রিক্যাল মেকানিক্যাল সব
ফিল্ডে আছে
সব জায়গায় Any other question, please? Okay, thank you very much. Once again.
My sincere thanks to our keynote speaker and all the session chair.
Yeah, 1 minute.
Bravo.
না ও আসলে মাইকটা কাজ করছে বুঝছেন
My sincere thanks to our respected keynote speaker and honorable session chair. Thank you again for sharing with us such valuable knowledge. It was really a productive session. Now we will move to our next technical session where we will be viewing some paper presentation.
আমরা রিজিউম করব 5 মিনিটের মধ্যে
We will start our next technical session within 5 to 10 minutes. Thank you, everyone.
এখন এটা বলবে কি মানে শেয়ার করবে কি
দুজন আছে থেকে দিচ্ছে
প্রেজেন্টাররা এসেছে
প্রেজেন্টেশন অনলাইন হবে একজন অফলাইন
না অনলাইনে তো সেটা এসেছে কি জয়েন করেছে
জয়েন করতে পারছিল না
নামগুলো কি আছে বলো চেক করো
না না
যারা প্রেজেন্ট করবে নামগুলো কি আছে
তাপস সংগ্রী বাকিগুলো দেবজয়
ঠিক আছে একটু দাও ছোট করার আগে তো সেশন চেয়ারে ঢুকতে হবে তারপরে নেই বলেছে
হ্যাঁ কৌশিক, তাহলে একটু ঢুকে যাও, এখন আমরা শুরু করে দিই। হ্যাঁ গুগল মিটের, হ্যাঁ হ্যাঁ ওই যে সেকেন্ড লিঙ্ক যেটা ছিল ওটা দিয়ে ঢোকে। ওকে ওকে। এই কৌশিক দাসগুপ্ত একজন ঢুকাবে, এখন ঢুকিয়ে দিবি। দেখ দাঁড়িয়ে দেখ। হ্যাঁ দুজন গাড়ি কিনতেছে।
একসাথে করবেন?
হ্যাঁ দুজন একসঙ্গে প্যারালাল, দুজনই করবো অনলাইন। এই জ্যোতি ঢুকে যাও, এখনই শুরু করবো।
হ্যালো স্যার।
ঢুকে যাও।
হ্যাঁ।
হ্যাঁ পরেই চলি আগে। না না কৌশিক স্যার হচ্ছে ওই যাকে সঠিকটা বললো বলো, উনি হচ্ছে কল্যাণী গভর্নমেন্টের এই ছবি, আর এই হচ্ছে বেঙ্গল স্টক টেকনোলজি ছিল। কি আছে দেখতে গেলে তাপস সিংড়ি আছে না, কি আছে?
স্যার আমি কি পিপিটিটা শেয়ার করব?
হ্যাঁ তুলিকা ঢোকো।
না আমি কি পিপিটিটা শেয়ার করব?
ও তো দেখাচ্ছে না বাবু, তুমি কোনটা প্রথমটা, কিন্তু ওই সেকেন্ড লিঙ্কটা ছিল, আমি খেয়াল করিনি।
আমাকে বলছো?
পিডিএফটা আছে তোমার কাছে?
হ্যালো
সেকেন্ড লিঙ্ক লাস্ট পেজে দেওয়া আছে, দেখো যে লিঙ্কটা সেকেন্ড পেজের লাস্টে দেওয়া আছে লিঙ্কটা। হ্যাঁ আবার ট্রাই করো ঢুকিয়ে দেবো, আমরা তো এখন আছি।
আমি কি পিপিটিটা শেয়ার করব স্যার? হ্যালো
কে ঢুকলো?
হ্যালো হ্যালো
ঠিক আছে।
হ্যালো
ওদের যা 10 মিনিট করে দেবো, আছে বলে দিচ্ছি।
হ্যালো স্যার, আমি কি পিপিটিটা শেয়ার করব?
ঢুকে দেখতো কৌশিক দা, ভিতরে ও ওকে ওকে ঢুকে আছে, ওকে থ্যাংকস।
মাইকটা অফ করো। আরে আমাদের মাইকটা অফ করো।
এটা কি খোলা আছে নাকি? এটা বন্ধ। কৌশিক স্যার, আর ইউ দেয়ার? কৌশিক স্যার,
No, he is not joined.
হ্যালো।
হ্যাঁ কৌশিক স্যার, ওকে ওকে, উইল স্টার্ট আফটার 5 minutes.
All the by the All India Council for Technical Education and Department of Science books and co-edited reputed of the Optical Society or OSI, Indian Society for Computing associate member of the Institute of Engineers India, Chartered Engineer India of the Institute of Engineers India. Dr. Kaushik is a regular reviewer in reputed journals like Applied Soft Computing, IEEE Transaction of Circuits and Systems Video Technology, Computers and Electrical Engineering, Wireless Personal Communications, SN Computer Science Sensors, IET Communications, Indonesian Journal of Electrical Engineering and Computer Science, etc. He has performed as Program Chair of CICBA 2018 and CICBA 2023. He has been invited as TPC member for many international conferences like IEEE SET STP CPS 2023, ICR CICN 2015, ICIC 2016, ICR CICN 2016, CIMTA 2013, NetCom 2009, CSI 2012, etc. Dr. Dashgupta acts as freelancing consultant for different networking projects in central and state academic and research institutes. He is also the faculty advisor of GDSC, Algorand Blockchain Foundation, Code Chef KGEC chapter, and acts as jury for coding competitions and hackathons. Dr. Kaushik is interested in real life applications based on principles and techniques from the paradigm of computational intelligence, biomedical and healthcare, blockchain, evolutionary and adaptive intelligence systems, computer vision. Welcome, sir, to the session. Now we'd like to introduce our second Honorable Session Chair, Dr. Jyoti Shekhar Banerjee. He is currently serving as the head of the Department in Computer Science and Engineering, AI and ML, Department at the Bengal Institute of Technology, Kolkata. He is also the professor in charge R&D and consultancy cell and nodal officer of the IPR cell of BIT. Since 2024, he also works as a remote researcher in the Ithaca Lab at the Department of Electrical and Computer Engineering, University of Western Macedonia, Greece. He is the former remote research fellow of the Cognitive Computing and Brain Informatics Research Group (CCBI) at Nottingham Trent University in NTU, UK. Dr. Banerjee he did his postdoctoral fellowship at Nottingham Trent University, UK, in the Department of Computer Science. He also completed the postgraduate diploma in IPR and TPM from Makaut, WB, and he has teaching and research experience spanning 20 years and completed one EIEI funded project. He is a member of CSI, IEEE, ISTE, IEI, ISOC, IAENG, and a fellow of IETE. He is present secretary cum treasurer of the ISTEWB section and secretary of the IETE Kolkata. He is the immediate past secretary of the Computer Society of India, Kolkata chapter. Welcome to the session, sir. Now the paper IDs for today's session are 1, 14, 19, 16, 17, 10. So I'd like to request our honorable session chairs to please host the session for the rest. Thank you, sir. Thank you, everyone.
Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay.
So paper number 1 first.
Thank you. Before to start the session, I would like to say something. That is, the presentation time should be 8 to 10 minutes, and the question answer session would be 5 minutes. I think it would be better with agreed with Dr. Dashgupta. Am I correct?
Yes, sir. Yes, sir. It's not an issue.
So we may proceed. So it is requested to all of the authors, all of the presenters, they need to follow the strict timeline, that is 8 to 10 minutes for presentation, and answer session. Their novelty, they should explain their novelty, specifically the result and discussion section and the existing comparison with the state of art literature available. Okay, so you may proceed with the first paper, that is paper ID 1.
Hello, sir. Am I audible?
Yes, you are absolutely audible.
Hello, sir.
You are audible.
Okay. Thank you, sir.
Share your screen.
Hello.
Yes, make it a full screen.
Okay, sir. Sir, give me some 1 minute, sir. Give me a minute, sir. Just. Hello, sir. My screen is shareable, sir?
Yes.
Okay. Very good afternoon, sir. Very good afternoon, everyone. And welcome to my presentation on evaluation of faculty teaching effectiveness through student feedback utilizing fuzzy Topsys method. As educators, we strive to provide the best possible learning experience for our students. However, evaluating the faculty teaching effectiveness can be a challenging task in our institutions. Myself, Dr. Dhrubajyoti Ghosh. I'm an associate professor from Om Dayal Group of Institutions, Uluberia, Howrah. Today, I will discuss the student feedback in evaluating faculty teaching effectiveness and present a novel approach using the fuzzy Topsys method. And my co-authors are Dr. Sandeep Des sir,
Okay, it is visible, sir.
Yes, it's visual and you are audible. Please start.
Okay. Thank you very much, sir. So before start the presentation, I must convey my gratitude to the organizing committee. They have organized such a doctoral symposium on intelligence enabling research, that is in short DOSIR 2024. My topic: optimizing feed-forward neural networks for medical image registration using science and teaching learning-based algorithm in fusion. Myself, Tapush Sangiri, I am the research scholar of North Bengal University, and my guide was under the supervision Dr. M.D. Aziz, Assistant Professor, North Bengal University. So, before discussion, the contents are background, motivation, and methodology, and result, conclusion, and reference. So, actually, the topic is image registration. What is meant by image registration? Actually, image registration is a method or technique where we show the two images are aligning is similar or not. So mainly the medical image registration part, that is the radiologist can help. They can help how to what the tumor existing and how much it will be malignant or not or benign or not. That is they can define. So using what I explore this thing. So using this one image registration technique, I use feed-forward neural network. Feed-forward neural network change the image registration, that is the image, actually the intensities of properties of image using feed-forward neural network, and I find out the some techniques, some optimizing algorithm, meta-heuristic optimizing algorithm. Here I use one novel algorithm, that is STPLU, sine cosine algorithm, and teaching learning based optimization algorithm. These two meta-heuristic algorithm we hybridize these two meta-heuristic algorithms, and it is work on better comparing to other some well-known optimization algorithm, that is particle swarm optimization, ant colony optimization, gray wolf optimization, and evaluation strategy. These five algorithms which I compared to our novel or meta-heuristic hybrid meta-heuristic optimization, better I can say, that is work on better. That is my topic. So we used to for the actually in image registration there are two of images we consider. One is monomodal and another is multimodal. In monomodal means when the images are captured the same device, like same CT scan or MRI or PET or SPI, whatever the only one single times variance and single. And when it's multi-dimensional cases or multimodal cases, you can compare the CT to MRI, MRI to CT, or PET to CT result. So in two cases arise there, one is monomodal and another is multimodal image. In monomodal image registration, I use here the similarity matrix, that is mean squared error, and another is mutual information. So my optimization technique, we told you that SCI-TLU optimizing technique we used for the optimizing the neural network loads. So mutual information, what is the mutual information? Mutual information is a matrix where we find similarity between two images. Here IF is the fixed image and IM is the probability. Using this probability matrix, we can find the similarity matrix. And another is the mean squared error matrix, which the value is the less value, that will be better. Because less value means the error is less, those that is similar to the images. That is the aligning two images are same or not. So when the error value is less, then we can say it is quite similar to this image. Or our algorithm will work better. So our objective, the primary objective is research to develop efficient and matching images because of image registration is matching or similarity checking two matrix or two images obtained from several modalities. Here two modalities have been used. We have been used, that is the monomodality and multimodality. And the performance of SCA-TL view, that is sine cosine adaptation teaching learning based optimization, is benchmarked against several well-known meta-heuristic algorithms, that is teaching learning based optimization, particle swarm optimization, and colony optimization, and Grey-Wolf optimization, and the evolution strategy algorithm, meta-heuristic algorithm, which I have used, we have been used. So our algorithm, our optimization, meta-heuristic optimization hybrid algorithm, that is SCA-PLU, works better or works good compared to other people. So that is our flow of work of first image, read the image, then pre-processing the image. Pre-processing is like there is a Gaussian mixture model or Gaussian or normalized, so that we can use the image noise or anything else reducted, then randomly initialize the first feed-forward network. After that, we apply the SCA-TLV optimization. Here, actually, normal feed-forward neural network, they use the backpricing, but here our gradient descent algorithm. But here we use SCA-TLV for optimization, and the optimized model is generated. Then after you can check the validation check, that these are what the image we have checked, that is the fixed image, and that is the fixed image, and comparing to the moving image, or what image you want to check, we want to check. Then if they are quite similar, then we can, if they are just, then we can say it's a register of the image, or if it is not, then we can say not registered. Again back to the optimizing, and again optimize the feed-forward neural network. And after that, we getting when the quite similar, then we can register similarities. We comparing these two matrix using SCA-TLV using feed-forward neural network. We find out the average and standard deviation of all the values. Every for 10 runs we check and define find out the average and standard deviation. And the accuracy of what I did, the why we are getting from the SCTLView method using feed-forward neural network. So that is in monomodal, that is 98% accuracy, and multimodal, that is 95% accuracy. After that, that the convergence graph, the graph is showing that what our algorithm is quite good compared to this one, compared to better output they have given. After that, we use some when we got some fine rank test, so we can rank the matrices according to our value of average and standard rate to comparison value, is to paired value. We take and we getting this interruption fine rank test. After that, our previous presenter already discussed, that is multi-criteria decision making, MCDM. Using MCDM top 6, we use and getting the rank of the method. The method we have used the 6 methods, that is CTLView, TLVFNN, TSO, and SQFNN, and GW with FNN, and PS with FNN. So according to this value, we are getting the comparison rank of this method 1, 2, 3, 4, 5, 6. And our conclusion, SCTLV is a hybrid meta-heuristic or algorithm that is hybridized these two sine cosine algorithm and teaching learning based optimization. And this meta-heuristic, this hybrid meta-heuristic algorithm we use to feed forward a neural network. So we can, and after that, we use that that is PCBA, DRC, and 40 dataset. That dataset, well-known dataset, that is we have used in this case. That database based MRI, there are 40 images, cancer genome atlas based invasive carcinoma, PCBA based dataset, and this 5 algorithm is used, and our algorithm works better. In future we can use feed-forward neural network better in convolution neural network or Hessian transformer. then it will I have you. So in future is our future dimension. And these are the references that the organizing committee of doctoral symposium, 2024, and under my supervision, Dr. Eli and Department of GST and you. Thank you, sir.
Okay. Any questions from audience? Don't remove the slides. Please go to the first slide. Any question from audience? Go to the first slide.
Go to the first slide.
Yes, sir. Yes, sir.
It is not showing.
Okay, it will show you, sir. Thank you.
Share your PPT.
Yes, sir. It is I'm signing it also. But, okay, sir. Now it is visible.
No.
No. Okay, sir. 1 minute.
Visible.
Okay.
Okay.
Okay, sir.
So basically, your work is on medical image registration.
Yes, sir. Image registration, medical image registration.
So what do you mean by image registration?
Image registration is a technique that will define two images are similar or not.
And why does this dissimilarity occur? Do you know?
Yeah, yes, sir.
Why does this dissimilarity between images occur?
Actually, if if a lungs, there is lungs, some nodules or tumor is there.
Huh?
So how radiologists can understand? That is, they can define, they can using the CT images or MRI, they can understand what.
No. Why does this dissimilarity between images occur? Because ultimately you are taking, if it is medical,
Yes, yes.
then you are taking from CT or MRI, whatever it is.
Yes, sir. It is.
So in that case, why does this difference occur?
If
How does this difference occur?
Okay, sir.
You know, what are the general types of difference in for which is to be taken care for image registration?
For image registration is taken care of, and if the it is similar, then the radiologist can understand how what the next.
Similar means pixel to pixel similarity you are
Yes, sir.
talking about.
Yes, sir. That is in intensity based pixel to
But-
pixel. Similar.
But in that case, there has to be some ground image, ground truth image, and then the other images. From which data set have you used?
Yes, sir. So,
Which data set have you used for this work?
I used this.
You have not mentioned any data set.
Yes, sir. In slide I have not mentioned. In last slide I just.
Also, you have not shown any images which
TCGA
are
data set. TCGA data set. That original data set for cancer genome atlas based university.
Dear presenter,
Yes, sir.
at first listen the question very
Okay.
carefully. Okay. Then
I was asking that as there is, you have not neither mentioned any data, nor you have given any example of the images of the data set and how they are they have got deteriorated and why image registration problem has to be handled on it. And so unless you are clear, unless we know that what is the problem definition or what thing you are solving, how is it possible for us within this 7 minutes to look at your paper? This is one thing which I am saying, which I have question for you.
Okay, sir.
Next is that
Yes.
did you perform any literature survey?
Yes, sir.
Did you perform any literature survey?
Yes, sir.
Okay. So from that literature survey, what did you found? There are no method for image registration. No.
There are a lot of methods in image registration, but nobody using feed forward neural network for the image registration.
What are you optimizing? You're optimizing the image registration or you're optimizing the feed forward neural network?
Actually, sir, I optimized first my feed forward neural network.
And then what you did? You optimized that.
Yes, sir. Actually, optimize that. The
Actually,
algorithm.
Using what?
I am completely agree with that with Dr. Dashgupta
Yes,
that
sir.
it seems from the name of the network itself. It is the problem.
Your
Yes, sir.
title looks a little bit confusing.
Yes.
You are optimizing feed-forward neural network for a particular problem definition, and you are optimizing it using a method sine cosine teaching learning
Yes, algorithm.
based fusion.
Actually, sir, in feed forward neural network, I optimize the feed forward neural network using this algorithm, that is SCTLB algorithm.
So that could have been used for any image, any type of problem definition. Why did you choose medical image registration only? This is one question. Maybe you have written it in your paper. I don't know.
Yes, sir.
And next is that if you have optimized your feed-forward neural network, then what was your fitness function which you have used? Because optimization needs some fitness function.
Yes, sir.
Many types of optimization need some fitness function from which you can.
Definitely, sir.
So I didn't see any fitness function in your slide.
Oh, sorry, mathematical that teaching learning that
Array,
optimization.
any fitness function has to be mathematics. It cannot be a theoretical one.
Okay, sir.
So I think you need to
Yes, sir.
take care of the suggestions which we are giving to you.
Incorporate.
I don't.
In
You
paper,
need to.
I incorporated.
You need to. If it is not there in your paper, then you need to incorporate.
No, it is
As
incorporated.
simple as that.
I should incorporate.
Okay, that is all from my side. Dr. Banerjee, if you have any question, you can.
Actually, I'm completely agree with you that the name of this paper, it is bit confusing that whether the author tried to optimize the neural process or image registration. It is bit confusing. So based on this, I do that the paper writing that has to be modified. And the most important thing is that image registration can be done by different types of techniques.
Yes,
So
sir.
why we are going to choose the said technique and what are the advantages? So have you written any comparative study in your
Yes, sir.
paper or in your
Yes, sir.
PhD? Do you have?
Yes, sir.
Please show the comparative study. I am not looking for the result actually.
Okay, sir. Okay, sir.
Why you are going to choose this? Actually, result sometimes don't tell the everything, right?
Yes.
Because what are the background facts? Why you are choosing this
Yes.
type of technique? Is there any
Hmm.
importance
Yes.
for choosing such
This one.
technique?
Okay, I got the point. I got the point. Sir. Okay, sir. I not incorporate the comparison literature study. I just incorporated this one. Okay, sir. Okay, this was we should incorporate. The literature survey is incorporate with this paper.
Are you showing something?
Okay. No, sir, I'm not showing this. Not showing this.
So one thing you need to
Okay,
make a
sir.
note that uh,
Okay, sir. Just
if you are not going to incorporate,
Okay,
listen
sir.
carefully. If you are not going to incorporate all of these points,
Okay,
so it's a bit difficult for getting chance in the
okay, sir.
proceeding. So be careful,
Okay.
right? So because the publisher may not accept, because these things are very much important with
Sure.
respect to your paper.
Sure, sir.
So amend your paper immediately, and whenever you are going to submit the camera ready paper, it should address all of these points. Okay.
Sure, sir. Sure, sir. Sure, sir. We should incorporate. Sure, sir.
Thank you.
Thank you, sir.
So you can leave. You can stop the sharing.
Close your presentation and next
Thank you, sir.
author.
Thank you very much, sir. Thank you.
Next author, paper ID 19.
Yes, sir.
Okay, please proceed.
So my screen is visible to you?
Yes.
Yes. Good afternoon, dear session chairs. Good afternoon to the organizing committee and to all the presenters and participants. With your permission, I'll start my presentation. My work is on automatic cluster detection in hyperspectral images using quantum Walrus optimizer. To give a
1
brief
minute,
background
ma'am.
of hyperspectral.
You need to
Yes, sir.
make the
Yes, sir.
screen
Yes, sir. Sorry.
full screen.
Sorry, sir. Yes, sir. Really sorry. Sorry. So to start of hyperspectral images are data cubes or multidimensional data cubes that consist of hundreds of spectral bands for each pixel. They can be said as a fingerprint for material. The spectral range or resolution varies from something between 126 to 512 spectral channels with a spatial resolution of 3 to 30 meters per pixel. The pixel information which is there is basically a detailed resolution of the spectrum of reflected light. The advantage or usefulness of hyperspectral images lies in the fact that they can detect specific properties of, say, soil or some hazardous chemical in the soil or some presence of some different kinds of carbon monoxide based on the spectral channels at which it is captured. There's a specific example, satellite-based atmospheric sensor from NASA called AIRS captures the image at 4.67 microband, detect carbon monoxide. The challenges with hyperspectral images is there that the high dimensionality of the hyperspectral image designate the individual cluster. And as a cluster validity index, the fitness function that has been used gives whenever we get a high the data set, as I said, the data set which has been used is the Wuhi long cow data set. This data set is captured in 2018. It has total, the ground truth image, if we see in this, in figure 1A, the ground truth image consists of 9 classes, which are most crops and other landscapes. 270 spectral bands are there, each of dimension 550 into 400 pixels each. We have compared
Hello,
the proposed algorithms with the
ma'am,
classical
are you
world.
speaking?
Yes, sir. Yes, sir.
We are not hearing anything.
No,
Sir, am I
actually,
audible?
yes, you are absolutely audible. Maybe there is network in Dr. Dashgupta's place.
Sir, should I continue?
Please continue.
Yes, sir. Thank you. We have compared the.
So now you can hear Dr. Dashgupta. Hello, Dr. Dashgupta, is it okay for you? You please continue.
Sure. Yes, sir. Fine, sir. So in table 1, we have compared the mean and standard deviation and times, whichever is taken for the algorithms to converge. As we can see, based algorithm takes a much lesser time than the qubit and the classical algorithm. The optimals, which are 7 for the qubit one and 4 for the classical algorithm, and the number of classes in the original data set is 9. So we can see the quitrit one has a better optimized result. 4 are considered to get to understand the quality of the cluster. So in that also, the higher F score or an F dash score perform better when it has a higher value to the maximization function. So in this, we can see that the critical one.